Okay, so in this video we're going to look at data frames, and data frames are a format for storing data, and they're really just like tables, but R provides lots of really useful functions to handle them, so they're a good way to work. So for this video I'm going to go to the Moodle site and I'm going to download the data for this exercise. So there, that's downloaded, and actually it should have appeared in my desktop here. And you might have to go and look at the downloads folder of your browser in order to find that. But I would copy it to the desktop. Now we want to import that into R. So the problem is R is not in that directory by default. Okay. This is the directory it's in, and this indicates my home directory. This might be different for you. So what we want to do is we want to move R into the desktop. Now we can do that with this. We can do that on the command line, but perhaps the easiest way is to go up here to the miscellaneous menu item and go to change working directory. Okay, so now I'm going to move to the desktop, which is where the body brain mass data file is, and I'm going to go to open, and you can see up here that R is now in the desktop. So what we're going to do here is we're going to read the data into R. Okay, so we can do that using what's called read.table. So I'm going to call this mass frame. You'll see why in a second. Read.table. I'm going to start typing body brain mass and press tab. Now, because R is in the desktop directory, it can see that by pressing tab. And if that tab complete doesn't work, then you're not in the same directory as the data file, which is here. Okay. So actually, we need to also specify another argument, which is header equals true, and that tells read.table that the first line is column headings. So I'm going to do that, and that's read in OK. We can use the dim function, which tells us the dimensions of the data frame. We have 27 rows and 3 columns, so it's always rows and then columns. Okay, so we can actually look at the first few rows using the head function. Okay, so this prints out the first 6 rows from the data frame, and what you can see is the first column contains an animal, so you have an animal name. We have the second column contains its mass, the body mass in kilograms, and you also have in the third column the brain mass in grams. Okay, so the column headers are animal, body mass, brain mass, and actually we can access those directly by using the names function. Okay, you can see that prints the names of the columns. So you can already see that this is quite a nice way to work. Each row corresponds to one data point or piece of data, and each piece of data has 2 values. Okay. And in general, the values in these columns can be numerical or categorical. Here we're just dealing with numerical data. Okay, so there's inbuilt functions to handle data frames. So one of them is summary. So we can go summary mass frame, and it prints out some information. So about the animals, it says there's 21 animals, but for the numerical data here, it prints the minimum value, the maximum value, the mean, the median, and so on. And we have that for both the body mass and the brain mass. Okay, so how do we access columns in the data frame? Well, for example, we can access the body mass column as follows. We use this $sign to indicate it's a variable of mass frame, and then we just get the numerical vector out of the data frame. So if I call mean on that, you can see that the mean here matches the mean that was calculated from the summary. Okay, so R provides a useful way to subset data frames. So the subset function is very useful. So we're going to subset mass frame, and we're going to take all those animals with body mass greater than 800 kilograms. And the subset function returns another data frame that's satisfying this logical constraint. So we can combine these logical constraints using the ampersand for and. So let's say and brain mass greater than 500, and you can see that we've further subsetted the data set in the data frame. So actually we've only got elephants that satisfy very large body mass and very large brain mass. Okay. So there's another way to subset data frames, and that's using the which function. So I can do exactly the same as previously, but using which, and I can say which mass frame dollar body mass is greater than 800 and mass frame dollar brain mass greater than 500. And what you can see here is which looks for all the rows of the data frame for which these are true. So it prints out, well, that's true on row 7 and it's true on row 15. So what we can do is we can put that back into the mass frame . So we can also access the columns, the rows and the columns in mass frame using the square brackets. This specifies the rows, and this empty part here says we're going to take all the columns. So if I click that, you can see that I've arrived at exactly the same point as here using subset. But whether you use which or subset depends on the circumstances. So let's talk about these square brackets a little bit more. So I can access the first row using this notation. You see Mountain Beaver. I can access the second row using number 2 there. And if I want to access a particular row and a particular column, then I can go 2, 2, so it should get me the body mass of the kind. Yes, which it does here. So there are many different ways to access variables in the data frame, and you'll get used to them over time as to which ones are more appropriate in different situations. Okay, so if let's calculate the summary of our data frame again. Okay, so you can see here that the body mass has a huge range. So the minimum goes from 0.02 up to about 87,000. Yeah. And similarly, brain mass goes from 0.4 up to 5,700. So in these cases, often statisticians look at log values instead of the actual values. So what we're going to do now is we're going to calculate a logged transform of those variables, and we're going to add them to the data frame. And you can see that is fairly easy. We can just say log. So we can just create a new variable like it already existed. And we're going to assign that new variable to log mass frame dollar body mass. There you go. So what that's done is calculate the log of all the values in the body mass column and then output them to this new column that we've added to data frame. So you can see this is a very flexible and nice way to add data to the data frame. We're going to calculate the log of the brain mass as well. There you go. Now if we go summary, well, first of all, let's print out our new mass frame. Print out the first 6 values. You can see in these 2 extra columns that we just defined are the log, the natural logs of the body mass and the brain mass. And you know, we can add variables to data frames in this manner. Okay, so we've manipulated the data frames and we've added some variables. What if we want to store our new data frame? Well, we can do that with the write.table function. So we're going to write out mass frame, and we're going to write it to body brain mass underscore new. So we're going to save the data frame to another text file, so we don't have to calculate these log transformations again. Now, there's various options to this. My personal choice is to not write the row names out. So I'm going to say row.names equals false, call.names equals true, which is default. So that's going to print out the column names. And also I'm going to turn off this quoting. So that's written the table into the current directory, which is here. And if I open that up in TextEdit, you can see it here.